The circle C has center A and equation here. Find the coordinates of A and the radius of C. The point C has coordinates minus 6, 2. Determine whether P lies inside C, on C, or outside C. The line L has equation y equals 2x plus 1. Show that L is a tangent to the circle C, and find the coordinates of Q, the point of contact of L and C. The point R has coordinates 4, 9, and R lies on L. Find ARQ, the angle of. Okay, so here's the question in summary form then. Find the coordinates of A and the radius of C. So let's write this in the standard form then. So here, part A, part 1, here. Well, half the x 6 to 3, so we get x plus 3 squared plus, and then half the minus 10 to minus 5, and write down squared. This is a 9, so we need a minus 9. This is a 25, when we expand the brackets, we need a minus 25 for it to disappear, and we already have a 14 here, so put that in, equals 0. So we have x plus 3 squared plus y minus 5 squared now equals what? So we've got 25, 34, minus 34 plus 14 is minus 20, and then move that over to become plus 20. 34 take 14, in other words, is 20. That's right. So that's everything moved around. So the coordinates of A has coordinates minus 3 is the center, and 5, and radius is equal to, this is r squared, so square root 20. 5 times 4, take the square root 4 out and leave the root 5 inside. 2 root 5 when we simplify the square root 20. Okay, p equals minus 6, 2. So P, this is part 2 now, minus 6, 2. So distance A to P then is equal to, well, the square root of, the difference in the x is squared, so that difference is 3, so that would be 3 squared is 9. The difference in the y squared is 3, so that square that would be 9 again. So we get the square root of 18, okay, which is less than the square root of 20. So P lies inside. Okay, that's part 2. Line L is y equals 2x plus 1. Show that L is tangential to C. So we've got our equation then. So this is part B. So L, the line L, is y equals 2x plus 1 here. Let's see what value we get for x then when we put this in here. So we'll get okay, what will we get? We'll get x plus 3 squared. We'll go back to the original form, I think is easiest. X squared plus y squared, which is this squared, 2x plus 1. And then what have we got? X plus y squared plus 6x minus 10y plus 6x minus 10y minus 10y plus 14 equals 0. Now we need to replace the y. Let's just check I've written it down correctly. Yeah, 6x minus 10y plus 14. The y needs to be replaced by 2x plus 1 plus 14 equals 0. Let's see what we get then. We get x squared. This bracket we get 4x squared, don't we? 2x times 2x. 2x times plus another 2x is 4x in the middle terms. And then the 1 times 1 is 1 plus the 6x. 10 2s are 20 minus 20x then. 10 1s minus 10 plus 14 equals 0. x squared and 4x squared is 5x squared. 4x, 6x is 10x minus 20x is minus 10x. So that's the x's done. And now the numbers 1 and 14 is 15 minus 10 is 5 equals 0. Divide by 5 all the way through. X plus 1 equals 0. And this is none other than x minus 1 squared, isn't it, when we factorize it? Which implies x equals 1. So just one solution, and that means the line is tangential to the circle. X equals 1. Okay, well, it may be there might be two y values, so we need to put this in now. On the line, y would equal 3, and that was 2x plus 1. And also, when x equals 1, what does y equal? Well, if we put it in here, say, x equals 1, we get 4 squared. So we get 16 plus y minus 5 squared equals 20. Uh, 20. So y minus 5 squared must equal 4. So y minus 5 is equal to square root of 4 is 2, plus or minus. So y is equal to, move the 5 over, 5 plus 2 is 7, or 5 minus 2 is 3. So the line here, the line cuts, touches the circle. Doesn't it, at the 3-point touches C at 1, 3. Because there was just one x value when it cuts at x equals 1. There's a single line. Okay, so that's that part done. Find the point of contact of Q, which we've done there. Last part then. Okay, let's go back up. Last part 2. R49 is on L. Find ARQ. ARQ. Ooh. So we got our circle. So I'm going to draw a little sketch of it. Just a quick, tiny little sketch, perhaps. R49 is on L. ARQ. Okay. So I'm going to need to do a sketch of this. Let's just do a quick one here. Because of space, no, I haven't got much room. So the center was minus 3 and 5. Here. That was minus 3 and 5. And the radius was root 20. So it's a circle that looks like this. Coming around here. Yep, around here. Like so. It crosses this because it's bigger than 3, the radius, but it doesn't cross this diagonal because it's not as big as this triangular length here, because it's only root 20 as the radius. So it comes in there somewhere. So there's a quick sketch. Y equals 2x plus 1. To be honest with you, that line looks like it goes like that. There. And that was tangential at Q, wasn't it? And Q had the coordinates 1, 3. So, minus 3, 5, so 1, 3. And that was Q. Okay. And then, what was the R49 is on L. So R's up here. This is the center A. And find the angle ARQ. So there's A, there's R, and there's Q. Okay. So I've got the orientation. Let's put it in then. ARQ. So we've got A. Oops. ARQ. Okay, so here's A, and that was the coordinate of the center of the circle. Q was at 1, 3, and R is at 4, 9, wasn't it? And we need to find out the angle, oops, ARQ. ARQ, here we go. This angle here. We know this distance here is root 20, because Q lies on the radius of the circle. This distance here is 3, 6. Yeah, just do a triangle thing for this distance here. We got a difference in the x's of 3, so that would be 9 when you square it. So it's the square root of 9, 3 squared, and then this difference is 6, so that would be 36. 36 and 9 is root 45. So tangent of the angle then, tan alpha, will be root 20 over root 45. So alpha is equal to then, so let's tap it in the calculator, shift tan, root 20, outside the square root, divided by square root of 45, outside the square root, close bracket, shift tan, 33.69 degrees. 33.69 degrees, and that's to 2 decimal places.